use natural logarithms. Now, if you have worked with common logarithms or other logarithms, you already have the basic idea, but the big difference is that natural logarithms have a base of e. So if you think about a log, so let's just say log of x, the base is e. Now, oftentimes, if we have a base of e, we don't write it like this. We write it like this. Oops. Yeah, no, that works. The natural log of x. So let me get rid of this x because I don't need an x through that. Log of x base e is the exact same as the natural log of x. Okay? Now, if we think through this, based off of your knowledge of common logs, which are these guys. Okay, so if we have the log of x base e, and let's say that equals y, then that means, right, we know that these, that means we know these are equivalent. E to the y equals x, right? Because we take the base raised to the y power to the x. So that means if we have the natural log of x and we want to change that to an exponential, we can do that by saying e to the y equals x, right? So if we had natural log of x equals y, that is the same as e to the y equals x, just to kind of put it all into perspective. Okay, so we are going to evaluate the following natural logs to 4 decimal places. Okay, so to do this, you don't even really need to know about the e to the x. That's kind of separate. Now we need to be able to use your calculator. So depending on your calculator, you should have an ln button somewhere. So we know that the basic log button is log. You're looking for something that looks like ln. So you're going to type in ln and then the number and hit enter. Okay, so like for letter A, you'll type in ln 14. So just to double check, if you type that in, your calculator is going to spit out 2.63905733, and this continues on, but we're going to chop it off, and you'll notice that we say we're going to round to 4 decimal places. So 1, 2, 3, 4. We look at the 5. 5 tells us to round up, so our answer is y equals 2.6391. Okay. Now we're going to do the natural log of 28. Same idea. Punching in ln 28 into your calculator, hit enter, and you should get 3.33220451 ... Round to 4 places. 1, 2, 3, 4. 0 tells us to stay the same. 3.3322 is our value of y. And last but not least, the natural log of 6. Calculator will spit at you 1.7917599469. 1, 2, 3, 4. 5 tells us to round up. So y equals 1.7918. Now, I do want to point out just something because I think it's important that you understand why this all works. So we know an equivalent to this last one, right? Base of e, e to the y equals 6. Now, hopefully we remember that e is a constant that is basically 2.71828. It goes on forever. But if you look at this and just say, okay, it's 2.7, let's just say 2.7 raised to a power equals 6. Well, if it was 2 squared, it's 4. And if it was 3 squared, it is 9. But 2.7 is somewhere between these two. So my answer, when I think about, if I square it, I'm getting 6. So I'm not going to be squaring it, because if I square 2.7, it's going to be bigger than that, right? So that's why we're thinking an exponent is about 1.8. I don't know if that made sense, but what I'm saying is you should have an idea of saying, okay, 2.7. If you type into your calculator 2.7 squared, you get 7.29. Okay, so let me change colors. 2.7 squared is 7.29. But my answer is 6. So that's why I'm saying we needed an exponent smaller than 2, which is 1.7918. So if you're thinking like, does my answer make sense? You can kind of rewrite it as an exponential. If I take e, right, type in your calculator hold on, let me give myself a little area here. If I take E and put 1.7918, okay, so this is a way you can check your work. E raised to the 1.7918 into my calculator, I get 6.0002. So you can see it's very, very close to 6. And we rounded, so that makes sense. So in case you want to check your work. Now, I do want to go this way and say rewrite and evaluate to 4 decimal places. Okay, so now we're working backwards. We have the exponential piece. How do I write this as a logarithm? Well, if it's base E, then I know I have a natural log. And just like with common logs, if the x is with the base in the exponential, it cannot be with the base in the log. So I end up with the natural log of 17 equals x. So when I type in ln 17, again, let's go to 4 decimal places, I end up with an answer of 2.8332. And then letter B, again, we have a base of E, so natural log of 70 equals x. Type in ln 70 into your calculator into 4 decimal places, 4.2485. So being able to maneuver between exponential and logarithm will really help you be able to evaluate different functions.